Okay, so we are going to go ahead and solve the last two story problems we didn't get through in class today. Because of time, I wanted to make sure you could at least get started in your work, so if you had any questions, you could talk to me. So we're going to look at the last two problems that were on today's homework or on today's lesson. And then I'll post the link onto our OneNote. So we're reading this one, and it says, the entry fee to a dance is $3. The cost per snack is $2. The total cost y is represented by the equation y equals 2x plus 3. So that's nice that they gave us the equation. We didn't have to think about it. A couple things I want to point out, though. On this, the entry fee to a dance is $3. This, when they give us this total, this is going to be our y-intercept. Or, as in our equation, this will be our b. The cost per snack, when we see the word per, that's usually going to give us a little sign that we're probably seeing our slope, because slope is going to be timesing by our x. So I'm going to see that this 2, that is going to end up being my slope. That is what's being times by x. Now we're going to go ahead with number 1, and it says graph the equation. Okay, so it shouldn't be too hard for us to do. We know that my y-intercept is the first thing I want to know. My y-intercept is 3. So I'm going to go 1, 2, 3. I'm going to go ahead and graph that right there. And then I want to write down my slope. M equals, and of course my slope, like I said before, is 2. So I'm going to say 2, or it might help me to write it as a fraction. 2 over 1. So I'm going to raise 2, 1, 2, and over 1. And I like to try and do 3 points. Okay, I'm going to go ahead and put my line in. Actually, I got to use my mouse now to get this right on. Using the board didn't work that well. Good. And being kind of picky now, but it's okay. Alright. So I should have there. And an important thing to notice is this wasn't a straight line with arrows on both ends. This was our ray, because it had to start here. My line could not go farther down. I can't say my line goes this way, because that would mean I'm getting paid not to go to the dance. So we know that will not work. So we had a starting point, and now it goes on. Okay, find the total cost if you go to the dance and buy 6 snacks. Well, that should be easy. We have 0 here. We have 1, 2, 3, 4, 5, and 6. However, if I follow this line all the way up, I see that we're off our chart somewhere. But that's okay. I'm going to erase this though. It's okay that we can't see in our graph. I could either have bigger grid paper and do this, or I can just use our equation over here, y equals 2x plus 3. But they told us if we're buying 6 snacks, we're replacing that with our x. 6 snacks is x. Each snack costs $2. So now I'm going to say y, my total cost, is 2 times 6 plus 3. Remember, the plus 3 is the cost to get into the dance. 2 times 6 is 12, plus 3 is our total cost would be $15. So we're going to say our total cost to get into the dance and buy 6 snacks is $15. What do the slope and the y-intercept represent? I'm actually going to type on this one. I think that's easier than my handwriting. But I'm going to go ahead and say the slope, where am I So I'm going to say slope. So the slope on here, that is the cost per snack. Our slope was $2, so slope represented how much each snack cost. Then I'm going to go ahead and say my y-intercept. The y-intercept represented the cost to get into the dance. So our y-intercept was how much it cost us to get into the dance. That's why, just to get into the dance, it would cost me $3. If I bought no snacks, I could still go to the dance, but my cost still would have been $3. Alright, we're going to go to the last one. And it says, water usage. A new toilet model has 2 different flush settings in order to conserve water. Ooh, so I hear 2, I'm thinking 2 equations. I'm going to use different colors. One setting uses 1.6 gallons of water per flush. Ooh, there's that keyword per. So I'm already thinking in my head that this is my slope. And the other setting uses 0.8 gallons per flush. So I'm going to go ahead and think this is my second slope for that other equation. The total amount W, I'm going to use the third color, in gallons of water used in the first setting is given by the equation. Oh, that's good. W equals 1.6 F, or F is the number of times the toilet's flushed. Okay. The total amount of water used in the second setting of the equation is W equals 0.8 F. So I'm going to go ahead over here to my graph, and I'm going to make sure I don't mix this up. Since F, they told me, is the number of times the toilet's flushed, I see over here number of flushes on my graph. So I'm going to go ahead and just mark that this is F. And water used in gallons, this is my W. Okay. And remember, usually that's our X and our Y. So I'm making the little connection here. It says, A, graph both equations in the same coordinate plane. What do the slopes and W-intercept mean in the situation? So I know I'm going to have to solve the problem. I don't like using purple. That kind of was hard to read. Let's use this one. So I want to know what the slope and intercept mean in this situation. Okay, so first thing I'm going to have to do is I'm going to go ahead and have to graph this. I know the first thing I have is, for my first one, I have W equals 1.6 F. That's for my first equation. And my second flush setting was 0.8 F. Okay, so the way we're going to go ahead and solve this is a couple different ways. First, and the best way we are going to use, because it's not even whole numbers, is I'm going to make a table. And in this case, I would have just said X, but remember that's being replaced by F. And I'm going to say flushes F. And then we put in our equation. W equals 1.6 times F. And then I want to get out to my total amount of water. And I'm left with my coordinates. So remember, we did this before. So I'm going to do this for my first one. My first flush setting. The numbers I'm going to use for F, how many flushes, is I'm going to use what was already given to me down here. 0, 2, 4, 6, 8, and 10. And to be really honest with you, I'm only going to use 3 of the flushes. Because once I have 3 points, I can graph this. So I'm going to go ahead and say W equals 1.6 times 0. Okay. If 0 was there, my water used would be 1.6 times 0 is 0. My first coordinate is 0, 0. If I'm thinking ahead, well, yeah, that makes sense. If I didn't flush the toilet, am I going to use any water? Then I'm going to go ahead and do 2 flushes. W equals 1.6 times 2. 1.6 times 2 is 3.2. So I'd have the coordinate 1.6 and 3.2. Oops. I'm sorry, I messed that up. I don't know why I said 1.6. My coordinate was 2. I had 2 flushes, and I get 3.2, which means if I flush a toilet twice, I'm going to use 3.2 gallons. I'm going to go to my 4th flush and show my work. W equals 1.6 gallons per flush times 4, and I should get 6.4, which means coordinates 4 flushes equals 6.4 gallons used. And I'm going to go ahead and graph this. So I have 0, 0. I'm going to zoom in my screen real quick for us. Okay, so my coordinates were, I have 0, 0. I have 2, 3 over 2, and 3.2 is going to be roughly in there. And 4, 6, 4. It's going to be right in there. So I'm going to use blue. Oops, and my line is off, so I want to redraw it. Okay, let's put those points back in. Something right in there, and right in there. Okay, I'm going to draw my line. Should be something like that. Now, I'm not done because this was only for my first toilet flush setting. So I have to redo this whole thing. I'm going to switch colors this time. But this time I'm going to use my second flushing, which was W equals, we have it over here, 0.8 per flush. Move my board over. And then we have our W and then our coordinates. I don't know if I probably put that line there. Okay. And now I'm going to go ahead with the same coordinates I did before. 0, 2, and 4. And we solve this just like before. W equals, oh, I forgot the F up here, 0.8 per flush. So if I had 0 flushes, I'd have 0.8 times 0, which gives me 0 water used. Same idea as before. Yeah, if I don't flush a toilet, I use no water. If I flushed it twice, I'd have 0.8 times 2, which is 1.6. So 2 to 1.6. And 4, 0.8 times 4 would give me 3.2. As you can see, once we set the table up, it doesn't take long to do. And zoom in just a touch. Maybe a little too much. And I'm going to try and graph these. My first was 0, 0. And then I had 2 and 1.6, so that should be right in there. And then I had 4 and 3.2. So this time when I graph it, to see it somewhere like that. It's kind of a bad graphing. And now I'm going to go back to my question. And it says, graph both equations. We did. What do the slope and y-intercepts mean? Okay, so in this one, in slope, in each one, our slope was telling us how much water is used in each flush. The w-intercept, our w-intercept, right here where our 0 is. Well, I made that comment every time we had our table. Our w-intercept was telling us, oops, we gotta get back in here, that no water is used if toilet isn't flushed. So yeah, it was telling me 0 gallons of water is being used, and where it was at was because there was no flushes. On B, how much more water, go to our equation here, how much more water is used by the first setting if the toilet's flushed 10 times? So on this one, I'm comparing the first to the second one. Well, because my graph is kind of small up here and it's kind of hard to see, especially when they get to decimals, all I'm really having to do is just do this whole graph again, 10 for number 10. If I did 10 flushes, I'm not sure why this ain't showing up on my board, I'd say W equals 1.6 times 10. Get my graph going down. I'd use 16. So that's telling me I'm going to use 16 gallons in my first flush setting. If I go over here and I put 10 in, I use 0.8 gallons per flush, and I'm doing it 10 times. And I'm going to use 8 gallons. So how much more water? I would have 16 minus 8, which is 8. So we'd say 8 more gallons are used by first toilet if flushed 10 times. Alright. Hopefully, give those story problems. You can now go ahead and solve the rest of your problems.